Hello everyone. For this tutorial video, I like to explain how to make the bricks you actually break in the Arkanoid style games. Although I will only demonstrate how to make one brick instead of the multiple bricks you see in finished products, as we want to focus on one thing at a time for playtesting purposes. A convenient way to make a sprite that has a very similar script to a sprite we already have is to duplicate the sprite whose script you want to copy, like so, and then revise the script as appropriate, as well as the graphic if it calls for it, which in this case it does. We know that in most Brick Breaker games, the bricks themselves do not move, only the ball and paddle. So we delete the when green flag clicked forever go to X mouse X thing. However, we copy the paddle because we want it to broadcast the reflect message just like the paddle does. And we can see it works somewhat, but the ball behaves strangely at certain angles. And this is because of the faulty collision box. So we will make the outline more thicker in order for the collision to be more apparent. However, even with the collision box fixed, it still behaves strangely. So the script is also part of the problem. In particular, if we break it down, we can see the script is saying that you reset the timer as soon as you hit it, and that this happens forever, i.e. it happens constantly as long as the ball is touching. So it does not broadcast the message one time, but rather broadcasts the message basically an infinite amount of times as long as the ball is touching. So we would fix this by checking if the timer is greater than 1 as an if conditional before the first one, so it becomes a new first if conditional. And it appears to work as intended now, at some of the angles, but not all of them. And because it is somewhat difficult to get the ball to hit the brick because of the way it bounces around the screen, and instead of having two if functions nested awkwardly, we should have an AND function to combine the two conditionals into one neat one. Like so. Because we fixed it for the brick, we should delete the old paddle so we can copy the fixed script from the brick. Just like we copied the old paddle to get the brick to begin with. So we make sure to bring back the script to update the X and Y position as appropriate. And we test to see if it works. And it seems to work fine for the paddle. So another theory that we could test to see why it doesn't work is that since we are pointing in 180 minus the direction, we should remember visually how it works. And we can see a problem is that when it approaches the brick moving northwest or northeast, it will get reflected southwest instead, or southeast if it is approaching from northeast. So 180 minus degree, although it is convenient for many situations, does not work for all of them, so you'll have to make the code more sophisticated. And we can see that if we approach while the ball moves northeast, that 90 plus any degree between 0 and 90, i.e. a northeast direction, would give us a northwest direction, which is what we want for a reflection. And similarly, to get a northeast reflection instead of the southwest reflection we currently have for northwest approaches, would technically be given by 180 minus the direction in real life math, but scratch angles work differently. So we would use 90 instead of 180, as 270, or straight down, is used as 0 instead. So we fixed the brick so that it gives two different types of broadcasts depending on what sides you hit. And it also should have a more appropriate collision box, so that it only counts as a hit if it hits the edges of the brick and not the red part on the inside. But we would first focus on the broadcast first, as it may not even be necessary to update the collision box to make it more subtle. So instead of broadcasting the message whenever it touches the ball period, it will now only broadcast the message if it touches the ball at the specific angles of the south part or the north part. And we will have the west and east parts as a separate sprite instead to broadcast a different message, although it will overlap to look like a full brick. We see if we try to edit the brick as a vector, you cannot get individual sides. It will highlight the entire perimeter for you. So you will convert it to bitmap, and then we can delete the west and east sides that way. we convert it back to a vector so that it is easy to scale and things like that. And then we duplicate the brick. But this time, the sprite will be only the left and right ends. The rest of the brick will not show. Like this. And making sure to fine-tune the edges as appropriate. Now that we have a convincing looking brick dissected into two parts, we can go to our code and have it broadcast a new message, which we will have the placeholder of message 2 to keep in theme of the original message 1. We next go back to the ball and ask when it receives message 2 and have it point in the direction of 90 minus the direction. And we see if it works. Unfortunately, it appears to still be receiving message 1 from the old brick, as you can see when it flashes. And this may be because not only is it hitting the inside area, the red area, but it may also be hitting the very edges of the bottom and top parts, while it is hitting the left and right parts. So we will first have to delete the empty area inside the brick. To see if that is our culprit. And it appears to be so. We will keep the empty area deleted so that the collision box does not get confused. We can actually simplify it further by deleting the vertical parts of the brick and emphasizing only the horizontal parts to test their functionality. And we can see the ball bounces at strange angles, so we will have to try a different angle instead for it to reflect by. So instead of 90, we will try 0. and it seems to work appropriately now. So know that we have our collisions squared away. We can create a separate entity that would act as the inside area of the brick. Like this, very carefully and skillfully. So now we see that there should be no code for it so far because we do not want it to detect if the ball is touching it. We only want it to serve as a graphic. However, it will still have to have some code later. As for example, we want the brick to disappear completely, including the inside area, whenever it is broken. So on that note, we have the initial brick sprite broadcast another message, and this message will be called death. Or maybe we should make it more appropriately brick die or brick break. And we wanted to broadcast it to itself as well to let it know that it should disappear. And we want the other edges of the brick to broadcast brick break as well, as we want it to break from any edge you hit it at. We also should not overlook that we should make it show when you restart the game, so that it does not stay hidden when you start a new game. Like so. We can add more polish to it by having a certain sound whenever the brick is broken. And you can technically have the sound play on any one of the three things that disappear. But we would use the first sprite just because it was the first sprite we used to begin with, so it is more organized that way. Luckily for us, the default sound that sprites come with, a popping sound, is very appropriate for a brick breaking game. So we will just have it start the sound pop whenever the brick is hitting. And it works like a charm. Now that I've explained how to program a brick in Scratch, I can move on to fixing the paddle, i.e. when it intercepts the ball, like this, in a similar manner to how we fixed the brick having wrong angles when you hit it. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.